Assalamualaikum and salam sejahtera. We from Group 10 we present Project Assignment 1 and 2 for Installation Design. Our group member are Nur Ain binti Adnan, Nur Karinisa Afiqah binti Abak, Wanida anak perempuan Bun Roy, Siti Atirah binti Muhammad Khairi and Nur Badrina binti Baharudin.
Assalamualaikum, my name is Nur Badrina binti Baharudin. My metric number is 211090969. Today I would like to present about our assignment project for Assignment 1 and Assignment 2. In this project 1, we need to calculate the lumen value to identify the correct lighting for the mouse and office. And there are 4 steps on how to calculate the lumen. First is calculate the room index. Second is select the maintenance factor. Third is determine the total lumen required. And fourth is divided lumen per lumen. The reason why we use the lumen method because first, simple and quick for initial estimate. Second is useful for standard lighting design, and third is help in budgeting and planning. In this slide, we show the calculation for the meeting room. The most important aspect of electrical installation is the selection of the right light. Lighting not only consists of sufficient lighting, but it also necessary for space. This is because it also affects various factors such as energy efficiency, health, and safety aspect. In this project, we have chosen fluorescent lamps 1x18, 2x18, 1x36, and 2x36 watt fluorescent lamp depends on the following reason. First is size area. A relatively small area and less lighting needs to be provided educate lighting for the space. A combination of 1x18 and 2x18 watt fluorescent lights provided uniform and glare-free lighting throughout the room. This is because the majority of the space in the office use 2x18 watt fluorescent light. After all, it has a ceiling size of 600 and 600, for example, the meeting room, the district engineer room, and the restroom. Second is purpose of space. An office is generally a room or an area used to do work. It can also refer to the building where the room or work area is located. Any office space can include various forms from a small space with a table and chairs to as wide as a floor or even the entire building specifically for a company. Third is energy efficiency. The lighting chosen should be energy efficient, using less power than other lighting options. This feature results in a reduced carbon footprint and saving in electricity bill for the office. Lastly is type of work. The lighting is also suitable for office environment. Appropriate lighting is necessary for computer work without creating glare on the computer screen.
Assalamualaikum and salam sejahtera. My name is Nur Karinisa Afiqah binti Abak. My metric number is 211090977. Today, I will explain about the lighting system of mouse. This is the Excel to complete the drawing of the lighting system for mouse. For example, tempat duduk lelaki. First of all, I calculate the area of the room. To calculate the area of the room, as we know, the length times with the width. The length and width can find in the drawing. For this length and width, my friend Nur Ain will explain how to calculate this in the drawing. For COU, I find the value of COU from the datasheet lamp that I use in this design. For this tempat duduk lelaki, I use the bar channel fitting. We took from the highest reflection and from the room's index. For this room, the room index is 0.17, so we took the nearest value that is 0.6, so the COU is 0.34. For the average lux, we took from the same figure of the location and we took a look the average lux of this room. So for this room, the average lux is 30. The MF is fixed 0.8. Next is for the lumen or LDL. For this room, I use the lamp 1x18 watt. So the lumen is 1325. From the actual lamp, I can know how much quantity lamp that I use in one room. The quantity lamp must be higher than the actual lamp that we calculate. For example, in this room, I got 0.15 for the actual lamp, so The quantity lamp that used in this room is 1 lamp. The impact of this essay to society and social is it will be misleading and it will be effect to the drawing and the one who will draw the drawing for the lightings. It will be affected by the quantity lamp that we will use in the design if the calculation from the first until the actual lamp is wrong. That's all from my part. Thank you.
Assalamualaikum. My name is Nur Ain binti Adnan and I will talk about MOS drawing for assignment 1 and assignment 2. First, I will explain about assignment 1, which is about designing a lighting system. For lighting, I'm using a 2x36 watt, 1x36 watt, 2x18 watt and 1x18 watt fluorescent lamp type, which is project batten. The casing of those lighting type is rear low bright and bare channel fitting. How do I get the spacing of each lamp is SHR max is equal to S which is spacing slash H which is SHR max is equal to 1.5 is stated in the luminaire. For example, lamp at the bilik wudu height is 3.39 meter and SHR max is 1.25 in the datasheet. So we can get the spacing of each light. In conclusion, fluorescent lamps are more energy efficient than traditional incandescent bulb, using about 75% less energy to produce the same amount of light. This efficiency translates into lower energy bill from fluorescent light, can enhance comfort and visibility in variety of location, including malls. On healthy concern, on the other hand, some individuals experience headache and eye strains due to the sensitivity to the flicker and color rendering fluorescent light. In environment impact, fluorescent light bulbs' energy efficiency contribute to a reduction in overall electricity usage, which in turn reduce the release of greenhouse gases from power plants, particularly those that burn fossil fuel.
Salam sejahtera, my name is Wanina Anak Perempuan Bundoi, magic number 2110925TT. Today I would like to present design a lighting 1. First of all, you know mask the length and width of the room. Radio mounting height for the office standard is 3. Will to get the area is the length of the room multiply the weight of the room. For index room using the formula leg multiply the width divide mounting height bracket leg multiply with weight. COU from datasheet. Looking at the room index you get the type of lamp we choose. For example, 1.24 I choose 0.58 COU. Lamp choose according to the room. For example, meeting room is 300 lamp. Or choose from appendix from appendix or JKR. MX is fit 0.8. Type I choose from JMAN. For actual lamp, I use the formula that is lamp multiply leg and weight multiply width divide lumen multiply COU multiply MF. Quality lamp I get from calculation actual lamp is 5.61 and I choose 8 lamp. For example, I choose the meeting room. Interrupt to 20 lamp in the room with the actual calculation of the lamp was only 18.46.
Okay, hi. Assalamualaikum warahmatullahi wabarakatuh. My name is Siti Atira binti Muhammad Khairi. My metric number is 211092529. So today I will explain and I will present about assignment 1 lighting system. So for office, we know that it has 2 floors, which is ground floor and first floor. And from the slide, we can see the table of data. So for column length and width, the data we can get from AutoCAD. So first thing first, before we start the Excel table, we must measure the AutoCAD first. For length and width, we measure for each room at the first floor. Okay, for mounting height, we assume the height of the office is 3 meter, and why certain room be minus with 0.7, because the desk height for office is 0.7 and for industry is 0.85 meter. Okay, for room index, how we can get the value? Okay, so for room index, we use the formula which is length multiple with width and divided with mounting height multiple with value length plus width. And for COU, lumen, lux, we can get from datasheet. For actual length, we also have a formula which is lux multiple with length multiple with width and divided with lighting design lumen multiple with COU and multiple with maintenance factor MF. So for maintenance factor, the value is fixed 0.8, and so from the formula actual lamp quantity, we can get the value quantity lamp used. For the next slide, this is lux table, lumen table and COU datasheet that we use in this assignment. So for lux table and lumen table, I already highlight the part that we use. So example like in lux table, we use executive office, so the value we use is 300, and the lumen table for fluorescent 2 multiple 18 watt, we use the 2650. Okay, I will explain about what is SHR max. So basically, SHR max is equal to S divided H. So H is mounting height, and the value SHR max we can get from the data sheet. What is basically SHR max? So it is a distance from one lamp to another lamp. Okay, for the last slide, okay, this is overall the lighting design that we make, and the small part is I focus on the certain room that I already highlight the point in slide 1. Okay, I think that's all. Thank you.
So here is the conclusion for assignment 1. Each building or department has its criteria that we need to follow by using the JKR standard guideline. This guideline is also known as the Public Works Department JKR standard, which provide guideline for lighting design and requirement for various interior spaces and building, including stair. In this assignment, we can see some buildings require different luminaires, such as offices and corridor will have different luminaires value due to the operation in that area. Most have varying ceiling height in each room, hence lighting arrangement depends substantially on the room's height. How about lighting selection? Lighting selection is also necessary to ensure that our lighting specifications are met needs. By choosing good lighting and ensuring that the load efficiency and luminous need will be met. Finally, the design of the project must follow the design building because each building has different dimension and placement. Therefore, we must ensure that the design of the light and the installation of the lights according to the design of the building. For assignment 2, we need to calculate the load distribution for the rooms and the office. Why we need to do that? It is because the load calculations are important for determining the appropriate size of electrical components such as wire, switches, fuse, and circuit breaker to meet the demand of the connected load while complying with our electrical code and safety standard. What is load distribution? Load distribution is the amount of power consumed by an electrical device or system connected to an electrical circuit or network. Load is an important purpose for them to form an electrical system. It is very important to ensure that it can supply power safely and efficiently to all connected devices. Why load distribution very important? It is because when designing an electrical installation, engineers need to calculate the amount of expected load to ensure that the electrical system including wiring, circuit breaker and transformer can safely handle the expected power demand without overloading and causing safety hazards such as overheating or fire. In this slide, we show you a few examples from our calculation from our project. First, we calculate the connected load. Second is maximum demand. And third is the rated current. In this project, we need to do load balancing. Why we need to do load balancing? Is it important or not? Yes, it's very important. Load balancing is an important part of designing circuit for wiring system in every building. The electrical service panel has two sides, and balancing the load requires an equal division circuit between the two sides so that the load or power draw is approximately equal on both sides.
For this assignment 2, I will explain about the balancing load for the MOS. First is DB lighting. The quantity lamp, the location, and the lamp type is from the previous assignment 1 that I has been explained before this. To calculate the connected load, for example, bilik jenazah, 2 times with the wire 36 volt and plus with the balas 12. The total connected load is the connected load times with the quantity of the lamp. To get the maximum demand, the diversity factor of the lamp times with the TCR. For rated current, we just calculate by phase. For example, this bilik jenazah only use the yellow circuit, so we only calculate the yellow rated current. Formula is maximum demand divided by 230 times with the 0.85. MCB rated current for this lamp is same 6 ampere and the cable size also same 1.5 millimeter. As we can see, for exit sign and emergency lamp, they are in the one circuit. It cannot be combined with the other lamp. We got a balance. The difference between the value is still in the range 10 until 15%. For the DB socket, it's same calculation with the DB lighting. In this socket, we use a radial and ring connection. For ring connection, it must not be exceed than 10 socket, and for the radial, it cannot be exceed than 6 socket. The type of the socket can be referred from this table. I use the 13 ampere single and double socket. The MCB rating current also can be found from this table, 32 ampere, because we use a ring and radial connection. For this DB socket, we also got the balance load red, yellow, and blue rated current. For aircon type, the aircon type can be found from the datasheet, the aircon that we will use in this design. In this design, we will use the media aircon. For aircon, that only allowed 1 aircon per phase. The horsepower for the aircon can be calculated by the watt divided by 746 watt. For example, bilik imam 780 watt divided by 746 watt. So here I got 1.04 horsepower. So we use the aircon 1 horsepower in this room. For this bilik imam, we use the type of aircon MSXE 10CR DN8 because indoor and this room also small, so 1 horsepower will be enough for this room. For the calculation is same from the previous DB lighting and DB socket. The cable size for this aircon are same 4 mm. End of this calculation, I got the balance loads because there's only 5% different between the load. In this assignment, there are an issue to balance the load, but I find the solution to balance the load of yellow, blue and red rated current by rearrange the location until I got the balance load of the rated current. That's all from me.
Next, assignment 2 is about developing a balanced load for all distribution board design, which involve lighting, power socket, and air conditioning. I added the drawing of the power socket and air conditioning. First, for the lighting, wire pulling process are necessaries because we know which of the lighting are we connected to the red or yellow or blue wire, which is per phase of the wire. For the emergency light and exit sign, I separate the process because they conduct the important of safety function in the building and facilities. Like ceiling fan and kipas pelawas is connected to the other lighting system. Next, we move to the power socket at the most. As we can see, I don't use many sockets. It is located at the imam room, audio room, toilet, ruang solat terbuka, ruang solat, storeroom and mortuary. This is because of the usage of the power socket at the most are not so needed as at the office building. Lastly, about the air conditioning load. As the same of the power socket, I don't put so many aircon at the most. It's only at the ruang solat utama and bilik imam. It is because temperature control of the prayer halls is one of the main purpose of the air conditioning in mosques. This is especially important in hotter climes where it can get very hot during the prayer time. By keeping the temperature at a comfortable level, worshippers may concentrate on their prayers without being sidetracked by intense heat. In conclusion, the engineering design extends to a well-planned load distribution of power socket and air conditioning by strategically placing power sockets in essential areas such as the imam room, also the prayer hall. The design minimize unnecessary energy consumption and ensure the efficient of power use. Similarly, delimited by strategic placement of air conditioning units in the main prayer hall and Imam room addresses the specific needed for the temperature control, enhancing comfort during prayer without overburdening the electrical system. For society impact, the project focus on the efficient lighting and balanced load distribution significantly improve the functionality and safety of the most facilities. By ensuring reliability emergency light and appropriate temperature control, the design enhanced the worship experience, allowing congregants to focus on their spiritual activities without disruption. The thoughtful of placement of electrical component also reflect a deep understanding of the most unique needs, fostering a sense and community and well-being among its users. Thank you.
Assignment 2, calculation load for lighting, socket and aircon. The way to get the connected load is balas 6. So I choose meeting room because I choose lamp 2 multiply 1/8 for rental lamp. So 6 plus 1/8 plus 1/8 I get 48. Total connected that is using the formula connected load multiply with quality casing lamp. So diversity is fit 0.85. Maximum demand diversity multiply total connected load for current for get value rated current red, yellow and blue. We must do calculation maximum demand divide 230 multiply 0.865. To on rated current value cannot be accepted to be accepted 10% until 50%. The load value must be the same or not significantly different on 3 rated current. MCB 6 for lighting and cable is 1.5 mm. Continue with socket. Socket tab from appendix 1. For quality socket IC term of ring and radian. Ring 2.5 mm and 10 load. For meridian 4.0 mm and only 6 load. For single socket connected load 250 watt. For double socket 500. To get total connected load connected multiply quantity. Maximum demand total load multiply diversity. So rated current maximum demand divide 230 multiply 0.85. So I choose room, storeroom. Lastly, continue with aircon. Quantity aircon is 1 because I see the horsepower. Connected load for 2 horsepower is 1650. For 1.5 horsepower connected load is 1013. For 1 horsepower connected load 7018. For connected load multiply quantity diversity factor is 1. For get maximum demand diversity multiply total connected load. For rated current calculation is same as calculation on socket and lighting. MCB is 32 ampere. For cable I choose size 4 mm. For example, I choose document room. For calculation get 2.24 horsepower. Therefore, I choose 1.5 horsepower for aircon this room.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Siti Atirah binti Imam Khairi and I will explain about assignment 2 which is balancing load. In balancing load, we focus on rated current red, yellow and blue. So for 3 each data cannot be unbalanced. If unbalanced, it cannot be difference from 10% until 50%. Okay, for lighting balance load, for each way, it cannot exceed 10 loads. So for one way, we focus on 10 bulbs only. For power socket balance load, okay, in this kind of balance loads, it has two connection, which is ring and radial. For ring, the cable size we use is 2.5 millimeter, and it cannot exceed 10 points, which is connection from one socket to one socket. The circle is 10 socket only. And for radial connection, the cable size is 4 millimeter, and it cannot exceed 6 point, which is in the connection only have 6 socket only. Okay, this part, I will explain how to get the total connected load. Okay, we use the formula quantity multiple with connected load, and how to get the maximum demand. Okay, the total connected load we multiple with diversity factor, and we can get the maximum demand for each row. Okay, for diversity factor, lighting and power socket outlet and also aircon, it's different. For lighting, we use 0.8, and for power socket, we use 0.4, and for the aircon, we use 1. Okay, for aircon, the table is same like power socket and the lighting, and it's slightly different because it has another extra table to calculate the horsepower. Okay, basically the table for aircon, lamp and power socket in this assignment is actually same. But for aircon, it has extra table, which is we need to find the horsepower first. Next, we can know what's the type of aircon that we can use. Okay, I think that's all from me in this assignment. Thank you.
So, what can I conclude for assignment 2 is that effective load distribution is crucial for system performance, safety and reliability. Second is requires truth planning, proper component sizing and continuous monitoring. Third is to carry out careful load calculation to determine the expected power requirement of different electrical loads. Lastly, it is important to find the right place to put the distribution board so that it's easy for the maintenance process to be done. We must divide the distribution board into 3 things among them: is the socket, lights and air conditioning.